Hey guys, today I'm going to introduce the Boruvka's algorithm to find the minimum spanning tree. So how do we do this? Basically, in a given undirected connected graph G, we take 3 steps, and the first one is we take every vertex as a component, and we denote the new graph as T, and then we just look through every component and find the smallest weight H connecting to one component from another component, and then we locate the H to see if it's in T. If it's not, then we add it to T, and then we locate if all the components are connected into one. If no, then we go back to step 2 to do the same thing all over again. So let me show you how to do this. And okay, so for this example, before I show you how to implement this algorithm, one thing to mention is all the edges must be different, we just ignore all the edges and take every vertex as a component, as individual tree, and then from the component A, we can see the smallest weight H is 3 connecting to B, and it's not in T. This is T, it's not in T. Then we add it to T, and then we locate component D, and we can tell the smallest weight H is 6 connecting to E, and it's not in T, so we add it to T, and then we locate this component, and the smallest weight H is 12, and which connecting to this component, and it's not in T, so we add it to T, and the same thing all over again, and we find the smallest H between F and G. The smallest weight H coming out from F is 5, which connecting to G, and we can see the smallest H between the component A, B, D, E, and F, G is 8, and then we connect to we connect then with adding the H8, and now we've got 2 components left. One is A, B, D, E, F, G, this big component, and another one is C, and we can tell the smallest weight H connecting these 2 components is 11, and it's not in T, so we add it in T, and then we check yes, all the components are connected into one, so the process is done, and we have found the minimum spanning tree. So for this whole process, the time complexity is big O m log m. Why? Because every time when we go through the component, we just literally half the number of the components, and because we have to go through every edge, and under the loop, then we locate every component. So we have to times the number of edges. So the total tank complexity is m times log n. Yeah, that's it. Thank you guys.